Hello, grade 10 students. Once again, I am Ma'am Dea, and I am a grade 10 science teacher. And for today, we will be discussing Quarter 2, Module 6, which is all about mirrors. Our most essential learning competency for this discussion would be to predict the characteristics. When we say characteristics, we are referring to orientation, the type, and the magnification of images formed by plane and curved mirrors and lenses. So that is covered by S10 FE 2G-50. So this lesson revolves around the concept of reflection. Now, what is reflection? Reflection is defined as the bouncing of light rays off an object. So remember, the key term here is bouncing. Parang pag naglalaro kayo ng bola. Diba yung bola kapag yan ay inihagis natin at tumama sa floor, sa sahig, magbabounce yan, tatalbog. So, ganun din yung nangyayari sa light, nagre-reflect siya sa tuwing nakaka-encounter siya ng isang bagay. Ngayon, saan ba natin usually na-encounter ang reflection? So, nagkakaroon tayo ng reflection sa tubig, sa salamin, sa iba't ibang klase ng salamin. Meron din kasing salamin na nasa sasakyan, meron din yung salamin na lagi nating ginagamit sa bahay. Pero kung mapapansin natin, yung mga image na na-form sa mga salamin na yan, iba-iba. Minsan masyadong maliit, minsan malaki, pero mas madalas parehas lang. So ngayon, pag-aaralan natin kung ano-anong klaseng mirror ba yung na-encounter natin araw-araw. Punta tayo sa laws of reflection. There are two laws of reflection. Remember this. The first one is that the incident ray, the normal, and the reflected ray all lie in the same plane. So shortly, makikita natin kung ano ba yung ibig sabihin ng incident ray, ng normal, at ng reflected ray. Second one, the angle of incidence is equal to the angle of reflection. So dito sa ating drawing, makikita natin we have two angles, angle 1 and angle 2 symbolized by the Greek letter theta. So we can see here that for reflection, theta 1 is equal to theta 2. Alright? So halimbawa, to sample problem agad. We are asked here to find the angle of reflection, theta r, and angles A and B using the two laws that we have discussed a while ago. Alright, so let's switch to Jamboard. Ayan. So here we have identified the incident ray and the reflected ray. You can easily identify the incident ray by looking at the direction of the arrow. Yung incident ray, yan po yung papasok or papunta sa ating object. In this case, our object is the mirror. Ayan. So, makikita natin dito na meron tayong papasok na ray. This is your incident ray. Yung palabas, yun naman yung reflected ray. So, ano naman yung normal na sinasabi kanina dun sa first law of reflection natin? Sabi kanina sa first law of reflection, the incident ray, the reflected ray, and the normal all lie on the same plane. So when we say normal line, we are referring to the line perpendicular to our object, which sabi nga natin kanina is the mirror. Okay? So ano ba yung normal na yan? Ito yan, yung broken lines. Alright, so going back to our question, we are asked to find the angle of reflection, theta r, and the angles A and B. Going back to rule number 2 or the second law of reflection, sabi natin, the angle of incidence is equal to the angle of reflection. Remember, the angle of incidence and the angle of reflection are measured from the normal. So therefore, our angle of incidence is 35 degrees. And our angle of reflection will also be measured from the normal to the reflected ray. So therefore, if theta I is 35 degrees, then theta sub r is also 35 degrees. Alright, so nakuha po ba yan? Okay, next we are asked to solve for angles A and B. Dito, gagamitin nyo na yung nalalaman ninyo sa mathematics. As we can notice, okay, the normal line is perpendicular to our mirror. When we say perpendicular, anong angle nga yun? Ano yung angle measurement po natin kapag perpendicular? Okay, so pag sinabi nating perpendicular, tama, 90 degrees. So therefore, this one is 90 degrees. And also, this one, 90 degrees din siya. So, ibig sabihin, pag pinag-add po natin si angle A at si 35 degrees, ang lalabas dapat dyan ay 90 degrees. So, therefore, angle A would be 90 degrees minus 35 degrees. And ano yung lalabas dyan? Okay, correct. 55 degrees. Nakuha po. Similarly, for angle B, okay, since we are looking at the same set of measurements, 90 degrees minus 35 degrees din siya, and that is 55 degrees. So, B is 55 degrees. At the same time, A is also 55 degrees. O, diba, madali lang? Next problem. Ito naman. We are asked to find the angle of incidence, the angle of reflection, and angle A. So again, we will be combining what we have learned in physics, which is yung laws of reflection and your knowledge on angles to solve this problem. Okay, so we know that, again, this one is 90 degrees. So, ibig sabihin, if we add the measurement of 50 degrees and angle of incidence, we will get 90 degrees. And therefore, angle of incidence would be equal to ilan? Okay, very good. 40 degrees. How about your angle of reflection? Okay, very good. Your angle of reflection is also 40 degrees because of the second law of reflection that tells us that angle of incidence is equal to the angle of reflection. Tatandaan po natin yan. Now, to get angle A, we will again use our knowledge of angles. So, sabi nga natin, itong part na to dapat mag-add siya sa 90 degrees. So, the measurement of A would be 50 degrees as well. Okay, so nakuha po ba yan? Madali lang, di ba? Balik po tayo sa ating PowerPoint. So, next we will be discussing image characteristics. But first, we will be focusing on the most common type of mirror. And that is your plane mirror. When we say plane mirror, we are referring to flat mirrors. Ito yung mga mirror na usually nakikita natin sa bahay. And for images that are formed in plane mirrors, we can identify 5 characteristics. So what are these 5 characteristics? First, the image is virtual. Okay, so what is meant by a virtual image? When we say a virtual image, we are referring to an imaginary image. So this image is formed at the back of the mirror. Di ba pag nagsasalamin tayo, pag nakatingin tayo sa salamin, yung nakikita natin na image ay parang nasa likod ng mirror. So yun yung ibig sabihin natin sa virtual image. Also, an image formed in a plane mirror is erect or upright. So what is meant by upright? Kung tayo ay nananalamin at nakatayo tayo sa harap ng isang plane mirror, dapat yung image na nakikita natin nakatayo din. Hindi pwedeng nakabaligtad kasi kung nakabaligtad yun, okay, hindi plane mirror yon. The third image characteristic is that the image should be the same size as the object. So kung gaano ka kataas, dapat ganun din yung image na makikita mo sa iyong mirror. The next characteristic of an image formed by a plane mirror is that the image distance is equal to the object distance. So taking the mirror as our point of reference, kapag tayo ay nakatayo 1 meter from the plane mirror, yung image natin ay nakatayo din 1 meter at the back of the mirror. Okay, ngayon kapag umatras ka naman, naging 2 meters, di ba, malayo ka na sa mirror, pero makikita mo pa rin yung image mo. Yung iyong image, aatras din siya na magiging 2 meters din siya from the mirror. So, laging ganun yon. Image distance is the same as object distance. And finally, the image is laterally inverted. Ano ibig sabihin ng laterally inverted? If you face the mirror and you raise your right hand, yung image ninyo, ang nire-raise niya ay yung kanyang left hand. Okay? Or if you try to blink your right eye in front of the mirror, your image blinks his or her left eye. Yun yung ibig sabihin ng laterally inverted or laterally reversed. Now, all of these characteristics can be classified into what we call the LOST, L-O-S-T. Okay? L stands for location, O stands for orientation, S stands for size, and T stands for type of image. So these are very important because later on, when we go to curved mirrors, you will be encountering this lost again. Okay, so ano ba yung location natin sa plane mirror? Ito siya, image distance is equal to object distance. The orientation would be erect or upright. The size would be the same size as the object, and the type of image would be virtual. Dalawa lang naman yung type of image dyan, is either real or virtual. So in the case of a plane mirror, we have a virtual image. So if there are no questions, let's proceed to the next topic. This time, we will go to curved mirrors. Yung curved mirrors, hindi siya ganun ka-common sa mga households unlike the plane mirrors. However, we can still see them in establishments or kapag kayo pumupunta sa doktor, nakikita natin yung mga yan. And we have two types of curved mirrors. We have a concave mirror and a convex mirror. Kaya nga sila tinawag na curved mirrors because they have curved reflecting surfaces. So, anong pagkakaiba ni concave kay convex? Okay, so makikita natin dito sa ating mga image yung isa sa mga pagkakaiba ng images formed by concave mirrors and convex mirrors. You can see a change in the size of the image, which tells us that these types of mirrors are not plane mirrors because a while ago, we have discussed that plane mirrors have images that are of the same size as our object. Alright, so this time, nagbabago po yung size, so they are no longer classified as plane mirrors. So concave mirrors are also called converging mirrors. So why are they called converging mirrors? Because light rays converge at one point after they strike and are reflected from the surface. Pag sinabi natin converge, ibig sabihin yan, nagtatagpo sila at one point. Nagi-intersect. On the other hand, for a convex mirror, the other term is a diverging mirror. This is the opposite of a converging mirror kasi this time, light rays would diverge after they strike the mirror. So, opposite ng converge, diverge, naghihiwalay. Let's discuss concave or converging mirrors in detail. Ayan, ito po ibig sabihin natin kanina sa converging and diverging. Sabi nga natin, converging, they meet at one point. Whereas, when I say diverging, naghihiwalay po yung mga light rays. So again, let's discuss concave mirrors in detail. So these are examples of concave mirrors that you have at home, you may have at home. So yung mga makeup mirrors or yung mga mirror na ginagamit dun sa mga beauty shops, yung shaving mirror, at yung reflecting telescope. Actually, there are two types of mirrors in a reflecting telescope. We have a primary mirror, which is a concave mirror, and a secondary mirror, which is a plane mirror. Meron kasi tayong refracting telescope that uses lenses. Ito namang reflecting telescope, ang ginagamit naman niya ay mirrors. Concave mirrors produce both real and virtual images. It depends on where the object is situated. Kasi yung object, pwedeng ilagay mo yan ng malapit sa mirror, pwedeng malayo, and depende pa kung ano yung measurement niya, yung distance niya, exact distance niya from the mirror. So how do we identify that? Okay, so we have what we call ray diagrams. So ray diagramming is a method used to predict the characteristics of an image formed by curved mirrors. So we have here an example of a concave mirror, and we have letters F, C, and V. F stands for the focal point, and C stands for the center of curvature. So we have three important lines that we have to remember whenever we have an object placed in front of any type of mirror. So first, light rays parallel to the principal axis passes through or diverge from focus after reflection. So let's say yung object natin, yung arrow na makikita nyo sa screen, we will be using the tip of the arrow as our point. So sabi po rito, light rays parallel to the principal axis. Okay, yung principal axis, yun yung line sa gitna. Pag tumama yan sa ating mirror, papasok siya kay focus. Okay, next rule. Light rays passing through the focus will be reflected parallel. So pag nag-pass through si light ray kay focus, lalabas siya ng parallel naman sa principal axis. And then the third line, a light ray passing through or directed towards the center of curvature retraces its path after reflection. Babalik lang. So, ayan yung line na nandyan pa kanina na dapat ay natanggal. So, ayan. Pag pumasok siya sa C, babalik din siya through C. So, yung intersection ng tatlong reflected rays na yan yung magiging image form nung tip ng ating arrow. So, ang image natin ay mafo-form somewhere here. Okay? And makikita natin na ang ating image ay nakabaligtad, smaller, and real kasi nasa harap siya ng mirror. Okay, so we will have more of that in the next slides kasi in the next slides we will now be discussing the different types of images formed depending on where you place the object with regards to C, F, and V, which is the vertex of the mirror. So halimbawa, if you place your object at infinity, when we say infinity, napakalayo po niyan, the image will be formed at F, at the focal point, nakabaligtad, inverted, smaller, and real. Remember, if the image is in front of the mirror, it is considered real. Now, if you place your object beyond C, okay, lagpas lang ng C, ng onte, the image will be formed in between C and F, nakabaligtad, inverted, smaller, and still real. Now, if you place your object at C, the image will also be formed at C, still inverted, but now same size as your object, and the image would still be real. If the object is between C and F, ayan, makikita natin nasa gitna na siya ng C and F, anywhere between C and F, the image will be formed beyond C, inverted, larger than your object, and real. So nakikita nyo dyan, iniisa-isa natin yung lost na sinabi ko kanina. We have location, orientation, size, and type of image. Now, if you place your object at F, your image will be formed at infinity, inverted, infinitely large, sobrang laki, and real. Okay? So, ito medyo tricky itong characteristics ng image na to kasi sa ibang sources, ang nilalagay nila no image formed. Kasi nga naman, mahirap naman hanapin yung image na nasa infinity. When we say infinity, napakalayo, hindi natin alam kung saan eksakto, basta sobrang layo niya. So, sa ibang mga sources, ang nilalagay nila no image formed. If we move the object closer such that it is in between F and P or F and V, okay, the image will now be behind the mirror. So that is a signal that the image is now virtual. It is now upright, nakatayo, and it is now larger than your object. Just like what is shown in the ray diagram shown below. Alright, so that's all for concave mirrors. Let's move on to convex mirrors. Again, convex mirrors are mirrors which diverge light rays. So, saan natin usually nakikita si convex mirror? Yan ay kadalasan natin nakikita sa mga establishments, sa malls, sa 7-Eleven, at kung saan-saan na nangangailangan ng wider view. Pwede rin sa side mirrors ng mga sasakyan. So, bakit? Kasi itong convex mirrors, nagpo-produce sila ng wider view. Mas malaki yung kanilang nasasakop. Now, if we go to the ray diagram of a convex mirror, unlike the concave mirror that was discussed earlier, diba kanina sa concave mirror, ang daming lumabas na iba't ibang klase ng location, orientation, size, and type of image depending on where you put the object. In the case of a convex mirror, wherever you place the object, the result will be the same. The image will be the same. So, the image will be behind the mirror. Ibig sabihin, virtual siya. The image will be upright, nakatayo, but the image will be smaller. By the way, when we are drawing virtual images, we usually draw them with broken lines to indicate that they are virtual. Okay, but again, just to clarify, for the case of mirrors, whenever the image is formed at the back of the mirror, then the image is virtual. Okay? So, ma'am, ang hirap naman pong tandaan. Saan po eksakto? Kasi tiba kanina parang merong sinasabi na ang location niya in between C and F. Saktong between po ba, ma'am? Or baka mas malapit po sa mirror ang lalabas? Okay? When we are drawing, it's a bit difficult to identify the exact location of the image. as well as the exact size of the image. However, luckily, thanks to math, we are able to identify the exact location and the exact size of the image formed through equations. And we call these equations the mirror equation and the magnification equation. So this time, I will be introducing two equations. First is the mirror equation. 1 over f is equal to 1 over d sub o plus 1 over d sub I, where f is the focal length, d sub o is the distance of the object from the mirror, and d sub I is the distance of the image from the mirror. Okay? So ano yung mga kailangan nating tandaan na sign convention? Si f, positive siya pag concave mirror. Si f naman ay negative pag convex mirror. Si distance of image, positive siya pag real image. Pag naman negative siya, virtual image yon. Okay? So, next, we also have the magnification equation. That is hi over ho is equal to negative di over do. Wherein ho refers to the height of the object, hi refers to the height of the image, and do and di refer to distance of the object and distance of the image, respectively. So don't forget that there is a negative sign before the term di over do. Huwag po nating kakalimutan yan. Now, let's try to solve some problems. So, first problem. Determine the image distance and the image height for a 5 cm tall object placed 45 cm from a concave mirror having a focal length of 15 centimeters. So, dalawa ang pinapahanap sa atin, image distance and image height. So, first things first, we have to identify the given. So, we have a 5 centimeter tall object, so that would be HO. Placed 45 centimeters from a concave mirror, so that would be the distance of the object. Having a focal length of 15 centimeters. F is equal to positive 15.0 centimeters. So, bakit positive, ma'am? Kasi concave mirror po ang given. Sabi ko nga kanina, kapag concave, positive ang F. Kapag convex, negative ang ating F. So, dalawa ang ating hinahanap. We have image distance, DI, and we have image height, HI. So, dahil meron tayong involved na DI at HI, gagamit tayo ng dalawang formula. We have the mirror equation. And we also have the magnification equation. Okay, so for the first part, let's solve. Let's find DI. So we are given F and we are given DO, so we can easily solve DI. So 1 over F minus 1 over DO is equal to 1 over DI. And DI would be equal to 1 all over 1 over F minus 1 over DO. So, pwedeng i-substitute nyo na muna yung mga values bago kayo mag-manipulate. Pero ang ginagawa ko rito, nagde-derive ako ng equation. Okay, pagbaligtarin lang natin. One over 15 minus 1 over 45 is equal to, ayusin lang natin, medyo nawala siya. Okay, you can use your calculators to answer that. That will be 22.5 centimeters. Okay, so for part B, we are asked for the image height, which we can easily solve because we have now DI, we also have DO, and we also have HO. So HI over HO is equal to negative DI over DO. So HI over 5.00 is equal to negative 22.5. That's cm. Divided by DO, which is 45.0 centimeters. So HI would be 5 centimeters times negative 22.5 divided by 45. That would be negative 0.5. So HI would be equal to 5 times 0.5, and that is negative 2.5 centimeters. Itatanong nyo siguro, ma'am, ano pong yung ibig sabihin ng negative sa height? So, kapag negative ang height, ibig sabihin nun, nakabaligtad siya. Pero pag kinuha nyo yung kanyang absolute value, 2.5 centimeters, ibig sabihin, smaller siya kaysa sa ating object. Okay, so for example, i-drawing natin dito, no? Bawa ito yung ating concave mirror. Ang F ng ating concave mirror, ang ating focal length ay 45 centimeters. Ay, wrong. Ang F ng ating concave mirror ay 15 centimeters. So, therefore, ang C niya ay 30 centimeters. Times 2 lang kasi yan. Okay? Ang object natin ay nilagay 45 centimeters from the concave mirror. So, object beyond C ang dating niya. Okay? So, sabi kanina sa ating ray diagramming, balik tayo dito sa ating PowerPoint. Pag si object ay beyond C, the image will be between C and F, inverted, smaller, and drill. Okay, pag bumalik tayo dun sa ating drawing, sabi dito ang image natin ay nabuo 22.5 centimeters. So that would be in between 15 and 30. Tama? So around here. Smaller siya, about half of the height of our object, pero nakabaligtad, kaya negative po yung nakuha natin na value. So, yun yung ibig sabihin ng mga sign na nakukuha natin doon sa ating mga sinosolve. Okay? So next, I hope you have understood that problem. Let's go to problem number 2. A shopper standing 3.0 meters from a convex security mirror sees his image with a magnification of 0.25. What is the distance of the image from the shopper and where is his image located? Okay, so nakalagay dito, convex. Okay, so let's identify first the given quantities. So the shopper is standing 3.0 meters from a convex mirror. So therefore, the distance of the object, which is our shopper, is 3 meters. And the magnification is 0.25. So we are looking for the distance of the image from the shopper. So that is different from the distance of the image kasi when we say DO and DI, we are measuring from the mirror. This time, for letter A, we are asking for the distance from the shopper. And where is his image located? This is your DI. So here, I think we just need the magnification equation. Okay, so this is not solution but equation. So let's solve that. M is equal to negative DI over DO. We are looking for DI first. So that would be negative M times DO is equal to negative 0.25 times the distance of the object, which is 3 meters. That would be negative 0.75 meters. And that would be our answer for letter B. Okay, kasi we are looking for DI there. Nauna nating isolve si letter D. So, ano ibig sabihin ng negative value for DI? Again, just like what I have said a while ago, when DI is negative, it means that the image is virtual, which is true for convex because all images are virtual. So, pag drawing natin yan, ito si convex mirror. So, let's say this is your object, 3 meters. So, si image ay ito. Sabi dyan, 0.75 meters. This is your object. This is your image. So, from there, we can already identify our answer for letter A. Sabi dyan, what is the distance of the image from the shopper? So, that would be 3 meters plus 0.75 meters, and that is 3.75 meters. Alright? So, let's go to the final problem. A tall light bulb was placed a distance of 50 centimeters from a concave mirror having a focal length of 25 centimeters. Determine the image distance and the magnification of the image. So again, we are given a concave mirror. So ano ang binigay sa atin na values? We have DO equal to 50 centimeters. We have a focal length of 25 centimeters. And we are asked for image distance and the magnification. We don't need the height for the magnification. Instead, we just need the value of di and do. Okay, kasi our equations would be first your mirror equation, and we have m is equal to negative di over do. So, let's solve for di. This time, kanina nag-derive tayo ng equation. This time, isa-substitute natin para makita nyo yung ibang way ng pagsosolve. So, F is 25 centimeters. Sulat natin yung equation sa taas. Is equal to 1 over do, 50, plus 1 over di. So, ilipat natin si 50, 1 over 50 sa kabila. Magiging 1 over 25 minus 1 over 50 is equal to 1 over di. I-operate on the left side. We will be having 1 over 50 is equal to 1 over di. But we are looking for di. So, we get the reciprocal of the left side and the right side. So, what do we get? We will be getting di is equal to 50 centimeters. Positive si di, ibig sabihin real ang image na form. Now, the magnification, sabi ko nga kanina, kailangan lang natin ng di at do. That would be negative 50 centimeters over the do equal to 50 centimeters. So, m is equal to negative 1. Ano ibig sabihin po niyan? The object and the image have the same size, but the image is inverted. So, tingnan natin, analyze natin yung kanyang ray diagram. So, pag drawing po natin yan, concave mirror. So, the light bulb was placed 50 centimeters from a concave mirror having a focal length of 25 centimeters. So, this would be 25. Your C would be 50. Kasi doble lang ni F, si C. Nilagay natin si light bulb 50 centimeters from the concave mirror. So, nandito siya kay C. So, ibig sabihin, ano ibig sabihin yan? The object is at C. And if you remember, yung kanina diniscuss natin, kung babalikan nyo, when object is at C, your image will also be at C. Pero inverted siya. Inverted, real, same size. Okay? So, therefore, ayan, we are able to somehow connect the concepts we have discussed a while ago about the ray diagram and the mathematics which is given by the mirror equation and the magnification equation. So that's it for today. I hope that you have understood the discussion about mirrors and reflection for the different types of mirrors. So if you have questions, don't hesitate to comment them down on our comment section. Kapag may time ako, nagbabasa ako at sumasagot if kayang sagutin. So yun lamang po. Maraming salamat sa panonood po ng aking video and see you next time. Bye!